In this video, we're going to write equations for tangent lines. So a circle has a tangent. And what describes a tangent to a circle? A tangent is a line that intersects the circle in exactly one point, that no part of that line crosses through the interior of that circle. In order for that to happen, the tangent line must be perpendicular to the radius, which goes from the center to a point on the circle itself. That point on the circle where the tangent line crosses is also known as the point of tangency. So we want it to be perpendicular, which means we're going to have to think about slopes. And a reminder, slopes of perpendicular lines are opposite reciprocals. Exercise number 1, what we want to do is find the slope-intercept equation for a line that's tangent to a circle with a center of 4, -3 that passes through the point -2, 4. That is your point of tangency, so we want our line to contain this point. Now, in order for us to make a tangent line, and not a line that contains a chord or a diameter of the circle that goes through the inside of the circle, what we want to do is be perpendicular to the radius containing the center and this point. The very first thing I'm going to do is find the slope of this radius, doing the slope formula. The change in y, if I do 4 take away -3, that makes 7. Do the change of x, -2 minus the 4 would be -6. If I simplify this, I can't really simplify the fraction, but I like to move the negative to the top. I get the slope of that line is -7/6. So that's the slope of the radius. If I want a tangent line, what I'm going to do is find the slope that's perpendicular to the radius, which is the opposite reciprocal, +6/7. Now we have a little bit of a choice how we start, but we want our formula to be in slope-intercept form. That's y equals mx plus b. The choice we have to make is, do you want to write a point-slope formula first, or do you just want to start with y equals mx plus b? There's no shame in doing either way, but just a reminder, we don't want the tangent to pass through the center, or else that would make a diameter. We want it to pass through the point -2, +4, so that is on the outside of the circle with the exception of that one point. So here's what we're going to do. I'm going to use this point and use this perpendicular slope. I suppose we'll use point-slope form to get us started. Ultimately, we want to convert this into slope-intercept form, y equals mx plus b. I'm just confirming that I've plugged in my points correctly. I have. I can distribute your slope, our slope, and I'm going to leave this as a fraction because fractions are exact. I don't want to touch a calculator unless I have to. So we have the equation that's neither point slope nor slope intercept form. All I need to do is move this 4 to the other side, then it's y equals mx plus b. If I add 4 to the left side, it's going to cancel. When I add 4 to the right hand side, I'm actually going to add 28/7 because it's the equivalent fraction of 4 and I want to combine like terms. So y equals 6/7 x plus 40/7. This is the equation of the tangent line that passes through this point that's tangent to this circle. Our next exercise is a little bit more challenging. It says, consider the equation of this circle. Find the equations of 2 tangent lines to the circle that have a given slope of -1/2. Okay, here's what I do know, but I'm not sure where to begin. I know that this is the equation and I could find the circle's center and its radius doing that. I know that the circle might have more than one tangent line with this slope, but I'm not sure exactly where it will be. What I'm going to do is sketch a picture anytime I'm not sure of how to begin a question. I'm just going to try to visualize what I understand. I approximated 3 to the right and 5 units up, although this picture does not need to be too great. The square root of 20 is 2√5. I'm not sure that helps us too much. I know it's more than 4. I know it's less than 5. So if I go like in each direction, I can visualize a circle. If it's more than 4 but less than 5, then we're going to have a circle that does something like this. So it's going to look like that. Here's what I also need to know. I need to visualize where on my circle will have tangent lines with negative slopes. If I go from this point to that point, any point that's tangent will have a positive slope up in this upper left. In the upper right, tangent lines will have negative slopes, so I want to imagine that there's a point somewhere up here which will have a slope of -1/2, and pass through this tangent point, the point of tangency, with a slope of negative 1/2. Let's continue around the circle. Down here, these tangent lines will have positive slope, so I don't want anything in this region, but maybe down here I'll have a point that has a slope of negative 1/2. I should say I'll have a line that passes through a point of tangency with a slope of also negative 1/2. So I've pretty much figured out that there's a point up here and a point down there. What's important to remember is back in our directions, we said that in order for it to be a tangent line, it has to be perpendicular to a radius from the center to the point of tangency, which means if the slope of the tangent line is negative 1/2, the slope of this radius has to be equal to 2. Similarly, but in the opposite direction, this would also have a slope of positive 2. So I know that there is a line that will pass through that diameter that has a slope of 2, and it will also pass through the center. In order to find the locations of these 2 points, what I want to do is I want to make a system of equations for a line and this circle in order to obtain the points of tangency, and there will be 2 of them. First, let's find the equation of this line that would contain the diameter in the middle of that circle. What do I know? I know that the diameter will have a slope of 2, although it's tough to read and I apologize for that. We know that the slope of the diameter equals 2. We know that the diameter of the circle has to pass through the point 3, 5. I can build an equation once I have a slope and a point. This time I'm going to use y equals mx plus b, so the y coordinate equals the slope times the x-coordinate plus the y-intercept. Subtract 6 from both sides, negative 1 equals b. The line that would contain the diameter would have a y-intercept of negative 1, somewhere down there. So now what? In order to find the points of tangency, what I'm going to do is I'm going to create a system of equations to find where the circle and this line, they intersect. That will give us our 2 points of tangency. So I'll create a system containing the line, which contains our diameter, and our circle. Since these are not lined up, I don't want to use sort of the elimination technique that we've learned before, but I do notice the first equation is solved for y, which means I can plug the first equation in place of the y in our second equation. So our algebra skills will come in handy. This may take a little bit of time, but I have faith that we can do this. So inside of the parentheses, I'm going to put the 2x minus 1, the equation for the first equation, put those in some square brackets and square that, equals 20. So this is the setup. The quantity x minus 3 squared plus the quantity of 2x minus 1 minus 5 squared plus 20. I can combine some like terms and square things at the same time. If I square this, I get x squared minus 6x plus 9. When I combine the like terms, I get 2x minus 6. And if I square that, I'm going to get 4x squared minus 24x plus 36, which equals 20. Square the first, square the last, multiply first and last, and double. That's how I did these. Okay. Combine like terms on the left side. It looks like I have a quadratic equation, but the great news is I only have x to solve for. 5x squared minus 30x. See, plus 45 equals 20. Let's subtract 20 from both sides so that this equals 0. To solve a quadratic equation, one of the techniques is to get it in the standard form by setting it equal to 0. What do I notice about these 3 terms? All of these 3 terms have a greatest common factor of 5, which I can factor out. 5 times the quantity x squared minus 6x plus 5 equals 0. I can try to use quadratic formula, or I can try to factor. What are the 2 factors of positive 5, which also simultaneously add up to be negative 6? They would be x minus 5, x minus 1. This 5 goes on the outside. These multiply to make 5 and add up to be a negative 6. What's the solution? Can 5 equal 0? No. Can x minus 5 equal 0? Yes, when x equals 5. This reveals the x-coordinate of one of these 2 points. The other x-coordinate would be positive 1. So I'm guessing this one is to the left, this one is to the right. This has an x-coordinate of 1, and that has an x-coordinate of 5. In order to find the y-coordinate for each of these, I can plug them in either of these two equations. The simpler one to plug it in is the top equation. When x equals 5, y equals 9. When x equals 1, y equals 1. These are the 2 points of tangency. Now I need to create two equations that are tangent. What I do know is it has to contain the point of tangency, and the slope of each of these tangents would be negative 1/2 because it's perpendicular to that line. So I'm just going to leave this in point slope formula this way. It will save me some time, and we can use that time for our next video. But these would be our two solutions. These lines are perpendicular to the diameter. They pass through the 2 points of tangency. These are our two tangent lines with slopes of negative 1/2. See, I had faith that we could do this, and we just did it. Here's our next video.